Can't see me?
No, we can't.
Just your lovely picture.
That's weird.
Okay, we're live. Alright. Do you guys have any questions on the individual prep stuff?
I don't think so. I didn't.
I thought it was pretty self-explanatory.
Yeah, should we just go through each one and then do the quiz together like we've done before?
Yeah, sounds good.
All right. What notation is used to denote the probability of an event occurring?
I put PX.
Yeah.
Okay. Please state and describe the 3 rules of probability. So I just got this from the textbook. Probability is a number between 0 and 1. If you list the outcomes of a probability experiment, the probability that one of these outcomes will occur is 1. And the probability that an outcome will occur is 1 minus the probability that it will occur.
Okay.
guys
What does it mean to be random? When something is random, it follows a long-term pattern, but we usually do not know the outcome of the next experiment.
So let's talk about a couple to help me better understand that, some examples of that. So when something is random, it follows a long-term pattern, but we usually do not know the outcome. So like, so kind of like the idea of, what is it called? The one when you like you roll a dice. Let me see, and
So
then it starts to follow a pattern after that.
So what they're saying that the pattern one would be like if it was red, yellow, blue, red, yellow, blue, red, yellow, blue. That's not random. That's a predictable pattern. But the random pattern would be like you were saying, it's the dice. Like you roll it, and like in the study that they did, it rolled 6,000 times. There would be somewhat of a pattern, but you wouldn't know what it was. Like if you said red, yellow, blue, red, yellow, you know it's going to be blue. But when you roll a dice, you don't know if it's going to be 4. Is that right?
Yeah, it's kind of like you know it's going to be one of the numbers from 1 to 6. So each number has a 1 in a 6 chance of being rolled. So just over time, it's pretty similar, unless it's great.
Okay. Anything else with that? Any thoughts, Soraya? You want to share about that one?
You're good. You guys are all very good at this.
Okay.
I'll read the fourth one.
Okay.
What does the phrase discrete random variable mean? And I just put for the class, roughly speaking, a random variable is discrete if its values could be listed in principle, given enough time. So it's just like the dice, given it enough time, how many, I guess, probabilities there will be.
Yeah.
What's the best example for that one?
Probably a dice.
Just the dice, like the discrete random, because you just don't know what you're going to roll.
Yeah, I mean, you could also do like a penny. It could be 50-50 chance. I think it's just anything that has an equal probability of all of the options within that choice.
So what separates it, though, from being random and discrete random? What's the difference?
I'm wondering the same thing. Any thoughts?
So I think discrete random deals more with long term. So like it's not so discrete the longer you do it.
Okay, maybe I'll put in something.
Okay.
So for discrete random variable A, it's not a huge big deal. You will never see that word again, or that phrase again. But, so discrete means that it's a number, a whole number. So like the dice, it's 1, 2, 3, 4, 5, or 6. You know that for sure. Or the penny, it's either heads or tails. It can't be the middle.
Mm-hmm.
Does that make sense? So that's what makes it discrete, is that it's for sure one of those numbers.
Okay.
Cool.
Whereas like a truly random number in a number generator can give you 5.5 or something along those lines, right?
Okay. Okay.
Okay, so I'd like to just just to restate that. So a discrete random would be more of a it's forced, or it is going to be one of these numbers where and that's where you're doing a specific, the dice or the coin or something where you know it is going to be one of those options, where a generator or something else would give you point this or point that. I'm just restating it. That's correct? Okay. Part 2, I'll read 5. An 8-sided die has 8 possible outcomes for each roll. Okay, all these numbers. Calculate the probability of rolling a number greater than 5. Okay, and then, so like, that would just be that greater than 5 would be those 3 options, the 6, 7, or 8. Right?
So it'd be 3 8s.
Yeah.
Or 0.375.
Yeah. Yeah. Cool. And for number 6, it says calculate the probability of not getting a number greater than 5. So it's also including 5, so it's 5 8s.
Okay.
Right?
5. Sweet.
Okay.
Does anyone want to ask Soraya anything before we go on to the quiz, or do you want to share any extra knowledge? So.
I think we should do the homework before we do the quiz.
Oh, I forgot about the homework. Yes.
Yeah.
Definitely.
Okay. There's only 10 questions, not 20 million ones this time. It's good.
Yeah.
Okay, lesson 4 homework.
I'm not seeing it. Let's see. Group meeting.
Go under content, and then it's under the homework folder.
Thank you. I was just looking on those pages that you kind of flip through. What was it on there? It just says, okay, in here it just says group meeting. Where's the homework at?
So at the top, right under where it says Math 22 1B 12 Online, Spring 2016,
Uh-huh.
the little sub things, content is the first of them.
I'm there.
Okay, click on content.
Mm-hmm.
And then it says Lesson 4 homework.
Yeah.
Click on Lesson 4 homework. And then the first link is the homework.
Yeah. Cool.
Okay.
Alrighty. Let's go for it.
Sweet. Who wants to read the first one?
Is that in your own words, a list of 3 rules of probability?
Yeah.
Okay. That one, the first rule was the numbers have to be between 0 and 1, right?
It can't be greater than 1 or less. Yeah, between 1. Yeah.
Yeah. And then the second one is the sum of the probabilities in any probability is 1.
Mm-hmm.
And then the third one would the probability that an outcome will occur is 1 minus the probability that it will occur.
Yep.
Okay.
It's the same as the
Yeah.
prep assignment.
And then it's in the same one. It says a class survey is a statistic in a statistics class asks students to list which state they were from. The results of the survey are given in the following table. Use the information to answer questions 2 through 6. Okay.
Okay, I'll read the first one.
Okay.
It says one of the probabilities is missing from the table. What should that missing probability be if the table is supposed to be a probability distribution? Which rule of probability helped you answer this question? Okay. So.
Well, it has to equal 100%, right?
Yeah.
So the other would be you add all those up and subtract 100, and that's what the other would be, right?
Yes.
That would be the third rule.
I think it's the first rule. Or maybe it's not the first rule. It is the third rule, yes.
Okay, so you're saying to add all together and then subtract the 100.
Yeah. Okay, I got 38.3%.
Me too.
Okay.
Me too.
All right, who wants to read number 3?
I'll read it. Randomly select a student in class according to the table. What is the probability of selecting a student that is from Washington or Oregon?
Okay. So I would just add them.
Add them all together?
Just the Washington and Oregon one, so
Yeah.
you get 15.8%. Is that right? Let's do the homework. Did you guys get that?
So it's 9.8% plus 6% is what you're doing, right?
Mm-hmm.
Isn't
Okay.
it? Well, you can't add them up, can you? Because it says Washington or Oregon.
I think you do, Adam.
Because it's asking what the probability of selecting a student that is from Washington or Oregon. So you have to add them up because those are the only people that you're being asked if you're going to choose from those two states.
Yeah,
Is that right?
I think so. Because if you do anything else, then you're not getting the people from Washington or Oregon. The
You kind of
homework.
take everybody else out of the equation because it's only talking about Washington and Oregon.
Mm-hmm. The homework
So,
says
15.8?
15.8%. Yeah. Do you get it, Eddie?
Well, I was thinking if it says that it's selected from Washington or Oregon, I thought it'd be different probability since Washington is 9.8 and Oregon is 6.0. I was thinking if it said Washington and Oregon, I would think they would be added up and then given a percentage from that, but I guess not.
Well, correct me if I'm wrong. If you're selecting from the whole entire group and you select someone, I'm trying to explain it the way I'm understanding it. If you're randomly selecting from the whole group, that would be out of 100%. So if you're only going to select from those two, what percentage do those two make up that 100%? So the likelihood of you selecting Washington or Oregon will be 15.8 because that's the combined total of Washington and Oregon out of the 100%.
Okay.
I think that's a good explanation, Donna.
Okay.
Yep, I think you are good. Do you agree, Soraya?
Yeah.
Okay.
Yeah, silently, like, nodding my head.
Okay.
Great.
All right. Randomly select a student in the class according to the table. What is the probability of selecting a student that is not from Idaho? Which rule of probability helped you answer this question? So, not from Idaho. So, would you just minus the 21% from the 100?
Mm-hmm.
Okay. So, that's the 78.
78.1.
0.1.
Yeah.
Because it's that 9%. Okay, and then the rule, the probability of event not happening is equal to 1 minus. Okay,
Yeah, the
so
third one.
that third one,
Mhm.
because it's just taking away from the whole, from the 1%.
Yeah.
Okay. Eddie, who else wants to read?
I'll read it. Randomly select a student in the class according to the table. What is the probability of selecting a student that is not from Utah or California?
Okay. Same thing.
Yeah.
So subtract the California 10.9
And
And
the
then
Utah
Utah.
7.7.
7.7. 81.4, is that what you got?
Mm-hmm.
And
Everyone
it's the same rule, right?
Yeah, it is
I
still
tried
the
to
same.
put the rules next to it so that I can go back and look to see which would help. It's like, so if we study for an exam, we can pull up our homework. So
Yeah,
that,
that's smart.
because number 2 was rule, I'm looking at it because I didn't write it down.
3.
All of them have been.
Mm-hmm.
Okay.
Okay.
Well, number 2 can be a mix, though.
It can be,
Right?
You have to use the fact that they all add up to 1, which is rule 2. And then you apply rule 3 type idea.
So like in a quiz, it will probably have like one option, one of these options, and then this and that. Might give you an option of choosing both or something, or maybe select all apply.
Maybe select all apply. Or it could be where it's just straight up rule 3, where you straight up just say, well, it's all minus Idaho, like number 4.
okay. All right.
Okay. I'll read number 6. It says, randomly select a student in the class according to the table. What is the probability of selecting a student that is from Texas?
Well, would that just fall under the other category?
According to
Well-
the table, what is the probability of selecting a student from
Other
Texas?
just says other, so that could be any of the other states. We don't know what percentage of those are from actually Texas, so I would say that we can't answer it.
Yeah. Because they didn't break it down into all of the states. It was just other.
Let me look at the answer sheet really quick.
I would just say
It's
you
not
don't have
possible.
Yeah, it says not possible on the answer sheet.
Mhm.
Right.
Okay, number 7. In the finance industry, investors make decisions based on past and present performances of the market. A stock is a share in the ownership of a company. For example, if you were to purchase stock in McDonald's, you would own a small part of that company. If the company does well in the future, the value of your stock would be expected to rise. Then you could sell your shares in the company for a profit. Stocks are sold in a stock market. Using historic data, a market analyst forecasts that the probability is 0.30 that the value of McDonald's stock will go up by 60% in the next year. The analyst calculates that the probability that the stock will increase by 15% is 0.31. Some of the analysts' other forecasts are summarized in the table below.
Okay. Use the information in the table above to determine the probability that McDonald's stock will go down by 10% over the next year.
Okay.
So, what do we do at this point? Do we...
You have to make it equal 1, right? So the 0.3, 0.31, 0.15, 0.1, you have to make it equal 1. Is that right?
And just find what that missing is.
Yeah.
So would you take all those,
Add them up.
and minus them from 1? Okay.
Yeah. So it should be 0.14, is that right?
Yep.
Did you understand that? I don't want to talk over anyone if you don't understand it.
Well, okay. Well, either way, like I just did it backwards. Like I just added them all up, and it's 0.84, and so that's obviously the remaining is the 14. Or if I would have taken it from 1 or 100, and minus all of those.
Yeah. the way to remember it is just it has to equal 1.
Mhm.
And so if you're given numbers in your probability and you have that missing 1, you have to make whatever's left over, that has to make all the other numbers equal 1.
Okay. That's the number one rule. It's 1. 0 to 1. Okay. Next.
All right. Use the information in the table to determine the probability that McDonald's stock will go up by less than 16% over the next year. So,
%.
Oh,
Okay.
less than 15. I was like looking for 16 and I don't see it.
huh.
What do we do for this?
Well,
Using the information table, determine the probability that will go up by 16, less than 16%. So you have to find all the values are less than 16%?
no.
Is that what you do?
I don't think so.
Using the information table, determine the probability that McDonald's stock will go up by less than 16% over the next year. How would you figure that out?
Let me try something really quick.
I'll let you try it if it doesn't work. I can.
Okay.
Hmm. Oh.
Find it out something?
Getting there. We'll
Do
see.
you want me to explain it,
Or check.
or do you want me to give you more time to think about it?
Tell us.
I'm fine if you go ahead. Thank you, Soraya.
So it's saying what is a probability it will go up by less than 16%. So we can't include the negative numbers because those are the stock going down. And then up is less than 16, so we add the 15% and the 5%, those probabilities.
So,
Oh.
okay, you're saying because it's going up
Mm-hmm.
and less than 16% over there.
Those are going down. So it's
So it'd be
saying by-
0.46? Is that what it is?
yes, 0.46.
Okay, but, okay, so you're saying just add together first the 15 and the 5,
Uh-huh.
and then, okay.
That's it.
So that's 0.31 plus 0.15 equals 0.46.
Okay.
Does that make sense to
That
everyone?
does make sense.
15% plus 5%.
No, 15%. Yeah. That's right.
So 0.15.
No. 0.31 plus 0.15.
You take the 15% probability, and you take 5% probability, and you add the probability of it going up because it's asking you to determine the probability.
Got it.
That makes sense.
Sorry.
Oh, okay, so
Thanks, Soraya.
0.15.
So you
'Cause
don't do the negatives because that's going down. Is that what you said?
Yes, that's the probability that the stock will go down 10% or down 30%. But we don't
Okay.
want to know about what's going down. It's the stock will go up by less than.
So the change in price is the 5% and the 15 is positive, so that's going up. And then the 60% doesn't fall in it because it's over the 16%. Okay.
Yep.
Sorry, I'm still really confused on this one. You said 15 plus 5, which is 20, right?
Well, but we're looking at the probabilities of those percentage. So if you look at the 15%, the probability of it is the 0.31. So we take 0.31 plus the probability of 5%, which is 0.15. So it should be 0.46.
And then what do you do with that?
That's the answer, is 0.46.
Okay. Key is looking at what numbers are not above what they're asking for, not below, like the negative, and making sure that we keep track of that it's asking for the probability and not the percentage of that. Just restating that. Okay.
You have to also note that in your problem above, probability can be written as a percentage. So in the problem above with the states, those are percentages, but they can also be written as decimals.
Uh-huh.
Okay.
Do you see what I'm saying? In the states,
Yeah.
one as
Yeah.
percentages. Okay. Just make sure you know that they can be written as both. for either.
Okay. Using the information in the table, determine the probability that McDonald's stock will go up by exactly 10% over the next year. Okay, using the information table, stock will go up.
Exactly 10%?
I don't think it shows
Is the
that.
probability like 0? I don't know.
Using the information in the table, determine the point that McDonald's stock will go up.
I don't think we can. I'd say like 0. No,
But
I
isn't
can't
it,
do it.
it doesn't show us anything that changes exactly 10%.
I'm looking back in the reading to see like if they went over this, something like this. Soraya, do you know in the textbook if it explains that? I don't remember this.
Well, you can explain this using the rule of probability, actually. But I don't think they gave like an example like this. But you can explain this with the rule of probability.
Okay.
Let's look at the rules again.
So you can only have this probabilities because they equal 100%,
Yes.
or will equal 1. So if you can't, there's no other probability to be 10, because either it'll be over the 1 rule or less than 1.
So it's 0.
Yes.
Yeah.
It is 0.
Is it 0?
Yes,
Yeah.
it is.
Yeah.
It is 0.
Okay, but explain that to me again, maybe.
Eddie did a good job. I understood.
Yeah, say
the way
that. Say that again, Eddie.
So because there's no, because that question mark,
Yeah.
because the rest of whatever it is to make up 1, then if you're trying to get 10%, you'd have to add another digit in there for it to also have a probability of being 10%. So you can't, since the question mark was already the remaining to make that 1, then you can't have more than 1. So 10% couldn't be like 0.1 because
That'd be more than 1.
would be more than 1.
Okay. So that's why it's automatically 0.
Yeah.
Because it can't be over that. Okay.
Okay. You are thinking about investing in McDonald's stock. Is the value more likely to go up or go down over the next year?
More
I
likely
would
to
say go up.
15%.
I don't think it doesn't ask for a number. It just says up or down.
And we know that because, let's see, it's a value more likely to go up.
Because the highest probability here would be the 15% one, which is 0.31.
Well, I don't think we have to, because it goes from negative to positive. And so the probability is just increasing.
Because it's just,
The forecast is saying that McDonald's stock will go up by 60% in the next year. And so if it keeps going up that much, I would say that it's still increasing. I might be wrong, I don't know.
Not why I would say it's going up. So I would say it's more likely to go up because if you add all your numbers that are positives, then you get 0.76 versus it going down, which is 0.14 plus 0.1, 0.24.
Okay.
So if you add up the probability, it'll be going up. So the 0.15, 0.31, and 0.3, that's a higher probability than it going down, which is the 0.14 plus 0.1. Does that make sense to everyone?
That does.
So you add the positive probabilities and compare it to the negative probabilities, and whoever's the highest would give you the answer of the most likely?
Yes.
Okay.
Hmm.
So if actually the 60% was 0.1 and the negative 10 was I don't know, 0.8 or whatever, but like I know that doesn't all add up to 1, but just hypothetically, then you would go with the negatives, because if you add the negatives up, then it would be going down. It's more likely.
Basically, you just go with whatever's the greater
Yes.
to
Okay.
see where it's heading. Okay.
That makes sense.
Soraya, we'll just need you hanging out every now and then.
Yeah, why don't you join our group more often?
So I was like looking through the textbook, and I'm like, this is not. Anyway,
Okay.
I wasn't catching it.
What's the next thing on our list? The quiz?
Yeah.
Yeah? Okay, let's do the quiz.
Homework quiz. I'm going for it.
Not homework
Oh,
quiz.
No. Yeah.
Group meeting
Sorry.
quiz.
I just caught that. I was like, oh, shit.
Okay.
No.
Okay.
Thank you.
Group meeting quiz.
I'm all over the place today here.
All right.
Okay. Did you start yours yet?
I did.
Okay, I'm going to go ahead and start.
There's 13 questions.
Okie dokie.
All right.
Okay.
I love the first ones.
Hey, I just had a test on the first actual question about this today.
What were you doing? Or
Human blood typing.
oh,
That was my biology test today. It's fun.
Are you taking human biology this semester?
Yeah, that's my major.
Is that class hard?
Well,
It's a 4-credit class, right?
well, my major is human biology, so I'm taking biology, human anatomy and physiology, and all those chemistry and all those classes. So
This
it's hard.
semester?
yeah.
Yes.
Oh, I did the anatomy and physiology and chemistry already, and those, I hated chemistry.
Yeah, I passed.
Good
That's
for you.
awesome.
Yeah, it was good. Okay.
Was that 101, 105?
I took 105 and 106 already, yeah.
Alrighty.
I'm in biochemistry this semester.
Fun.
Great.
Good for you. All right. The blood types. Well, we got all this info. Human blood can be classified into one or basics of O, A, B, and AB, and the proportion of people in population of the United States, which each of these blood types is summarized in the following table. Okay, the blood types and proportions given in the table above define distribution. Define the distribution. Proportion.
Proportions contain probability. I'd say yeah.
Okay, because does it have anything to do with it becoming 100%? The 45, 40.
To become 1?
Yeah, to become 1. That it's not over 1.
Yeah, it has to be between 0 and 1.
But
Yeah,
because
It can't be over 1.
It
But-
is between 0 and 1.
yeah, so that'd be
It's
true.
actually equal to 1, yeah.
Well, I just looked at them, and it's just like just looking at them, they add up to
Yes.
Yeah.
1.
What is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places.
Okay.
Probability. So, O.
45%, right?
Because O,
Yeah, we don't add them all together or anything because it's only taking the O, right?
Mm-hmm.
Because Because it's not like asking for O and A or something like that.
So it's 0.45. Right.
Soraya, go ahead and stop us if we're ever wrong, but that's what makes sense to me.
Oh, I will stop you if you're wrong, but you guys are
Okay.
you guys are right.
Sweet.
Okay.
And you're just going off the table because it tells you the answer.
Yeah.
That's all it's asking.
Okay.
Okay. What is the probability that a randomly selected person will not have type O blood?
So then would you just take that 45 and minus it from the whole?
Yeah.
One.
So you just got 55?
Mm-hmm. Or it's 0.55.
0.55.
Yes.
I can dig these questions.
Yeah, hopefully our test is like this.
Okay. Carolyn Willis and her colleagues conducted a study in which the dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, Tangle, sorry, not Dangle. Tangle, I'm like thinking they're dangling. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowels containing urine were lined up in bowls. My reading is awesome.
Really gory.
I'm taking it to anatomy and physiology. Okay, bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. One of the bowls. Okay. If the dogs guess at random, if I'm ever reading something funky, let me know. What is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Okay, so
1.7.
So we 0.1.
1.7 because there's 7 bowls and they're taking 1 dog. Is that as simple? Is that too simple?
No,
Not 1.7. It's
no, it'd be 0.14. What are we rounding?
0.14. Yeah.
0.14. I think it says 3 decimal places. Yeah.
Okay,
So 143.
143.
Yeah.
Oops.
0.143?
Mhm.
Okay, tell me how you guys got that, please.
Because
Okay.
there were 7 specimens,
Uh-huh.
and if you select 1, is 1/7, and then you divide 1 by 7.
So 6 of the bowls are urine samples of patients with no bladder cancer, and 1 of the bowls is from a patient with bladder cancer. So the chances of the dog choosing the one with bladder cancer is 1/7, because there's 1 of them has cancer in the urine, whereas the other 6 don't.
Okay.
Does that make sense?
Totally. That's super simple.
If you
Got
go
it.
back to your homework, that's like on like the 2.1 of the homework. That's like the first practice thing that you do, just if you want to look at it.
Okay, thank you very much.
Uh-huh.
Okay. And that totally made sense to me once I just knew how to plug it into my calculator. Just 1 divided by 7.
Okay.
Okay.
In a combined...
Go ahead.
You read it.
Okay, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that a dog would do this well by random chance alone.
Stop.
Which of the following statements is most appropriate? Yes.
Reread the second to last sentence.
Okay, I'm sorry. I'll start all over. In
No,
a
no, no,
combined...
I want to note this sentence. This is going to be very important. So it is very...
The last sentence or the second?
Second to last. It is
It
very...
is very unlikely that the dog would do this well by random chance alone.
Okay, you can keep going. Sorry.
Okay. Which of the following statements is most appropriate? So this provides strong evidence that dogs can detect bladder cancer, or this is little evidence that dogs can detect bladder cancer.
I'd say it is strong evidence that the dogs can detect bladder cancer. Just because of the second sentence, as Soraya said.
Very unlikely that the dog would. Random chance. Okay. The second sentence in the thing. Let's see. Trying to lie down.
And that was with in like our lesson 1, right? Or probability. If it was really low, then it was chance that wasn't correct. Is that right? Do you remember in our lesson 1 when we learned?
Sure.
Okay.
You're talking about your null and alternative hypothesis.
Yeah.
If your p-value is low,
Yeah.
then yeah, it's kind of like that.
Okay.
Yeah. It's telling you that it's very unlikely that a dog could do this by chance. Therefore, they are doing very good job doing this. It's not a random guessing game for those
So
dogs.
they must be able to detect bladder cancer.
Yes.
Because it's such a difficult thing, but they are doing it. That's why we're saying this provides a strong evidence that they can do it, because they are doing it,
Yes.
22 times out of 54.
which is very
Which is
good.
better than you or I can do.
Yeah.
Well, I haven't tried, but
All right, so that provides strong evidence.
Yeah.
Okay, moving on. M&Ms are small chocolate candies. The M&Ms, I love that. The M&Ms website previously indicated that in the United States, the distribution of color in a bag of plain M&Ms is given in the following table. Okay, if you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Okay.
I think 13.
Mm-hmm.
So just the 13.
It is just 0.13. I was going to be divided by 1, but that's still 0.13.
Well, Catherine, it's good you clarified that. Okay, what is the probability that randomly selected candy is green? So we just add all those up and then just take the remaining, correct?
Subtract
Right.
it from 1.
From 1, yeah. Oh.
$1.16.
Yep. Do you guys get that?
Yeah.
Okay. Yep.
0.16.
So, I'll read the next one.
Okay.
What is the probability that a randomly selected candy is not green? That'll be 0.84.
Yeah, just the 84%.
Yeah.
But 0.84. 0.84.
Yeah, it's 0.84. Okay, I'll read the next one. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from CAPEX.com, or CAPEX. The following summary statistics were calculated. Half of the observations are less than or equal to what number?
Okay. So do we take all those and then just find the mean from that? Like add them all up and then divide it by the amount of units?
Well, the mean's already there, right?
Mm-hmm.
Yeah.
So is it 24.3?
Yeah.
Half the observations are less or equal to what number? So just 24.3.
I'd say it's 24.3. Is that right?
I disagree.
You disagree?
Okay, talk to us.
Kim, so I don't know if you guys have learned percentiles as well. Like, what is a percentile? So at this point, this is kind of what your median is what you're looking for here.
Hmm.
Your median is your halfway mark in the 5-number summary, right?
Yeah.
Right.
So for a percentile, we say, so the first quartile here is 22, right? So I would-
Right.
25%, so 25% of the people scored at 22 or lower than that.
Okay.
Okay, so that's how you say what a percentile is. That's how you interpret a percentile. So
Mhm.
this is the exact same thing. So the median is a halfway mark. So it's saying half of the people scored 24 or below.
There's 24.
That's right.
Mhm.
That makes sense.
So can someone tell me how to do the third quartile or the 75th percentile? How would you interpret it?
That's 75% or, well, the first one is 25% or lower, Q2 is 50% or lower, and then Q3 is 75% or lower.
Q3 is the 25 or 75.
Yeah. Is that right?
And so that's the 27.
Okay, so you'd say 75% of the people scored at or below the 27.
The 27.
That makes sense.
Okay, but for question 11, it's the 24.
Yes.
Because they gave you, instead of putting Q2, they put median in that chart. Is that how they ordered it? Because on the chart, I don't even see a Q2. They just,
yeah, Q2 is exactly the same as median
okay,
or the 50th percentile. They're all the
okay,
same.
okay.
Sweet. Okay.
So based on the information on the table above, the top 25% of the students scored above what number?
That would be your Q1, the 22.
The top 20%.
I would recommend reading the question again.
It says above, and Q1 is 25 or lower.
So this is after Q3.
So it'll be 27 or more.
Yeah, because
35.
based on the information of the table above, 25% of the students scored above what number?
So top 25 would be the 75%.
No, it'd be the maximum, right? Because the top 25, it's after quartile 3.
Yeah, the top 25.
Yeah.
Yeah,
So top 25
is the maximum.
Right, and that is between Q3 and the maximum, so it has to be 75 or more, 75% or more, so it'd be the maximum at 35?
No.
No?
No.
Based on the information.
I agree with Eddie. Is that your name, right, Eddie?
Yeah.
Okay. So he's saying, so you're looking at the wrong wording. You're looking at above what number? You should be looking at the top 25%. So that's on your 5-number summary thing. The top 25, so you get to 75%
Mm-hmm.
of the third quartile. The top 25 is starting at
The third quartile. Okay.
So that would be the 27. Does that make sense? They either scored 27 or above to be in the top 25.
Oh, it does make sense.
Okay, so 27 or above to be in the top 25. But when you do Q3, I thought Q3 was 75% or lower.
So if you look at 100 minus 75, that's 25%, right?
Right.
So we're not saying what's the lower 25. We're asking what the top 25% of people.
Top 25% of the students that scored above what number? Oh, okay. I was looking at the wrong part. Above what number? So above 27. Okay, I get it now. I'm sorry. It just took me a minute. That's a tricky one.
Uh-huh. Absolutely.
You have to really read the questions because one word can make it completely different.
Uh-huh.
Which of the following statements is not one of the 3 rules of probability? Probability and higher positive.
The C, if the probability
That's
is
what I
high,
was looking at.
Probably can be negative.
probability is low.
Low.
There's no negative.
I agree, because it would never go below the 0.
Right.
Well, I think this is just talking about the 3 rules of probability that we had to.
Right.
Yeah,
Yeah.
so that one's not one of them.
Nope.
So if the probability is high, then that's the one we're marking.
Right.
Yeah.
Okay. Do we feel good? Do we want to go back over anything?
No, I think we're good.
I think we're good.
Okay.
Okay. Here we go, ladies and gentlemen.
Uh-oh. What did mine just say? I have 2 unanswered ones. Hold on. Questions
Uh-oh.
1 and 2.
I was gonna say I
Oh,
one
I didn't
and
answer the first 2.
Oh no. Will you get a second attempt? Do you want to go back over the questions, Donna?
No, I didn't. It didn't let me submit it because it said I was missing 2.
Okay.
So it's okay.
Good.
I just didn't do those first 2 of like I participated.
Well, we can vouch for you.
Okay. Sweet.
Right.
So the
Sweet.
lesson learned from today was we have to really listen or read carefully because the wording can change the entire meaning of your answer.
Yeah,
Yeah.
the top or below or yeah.
Yeah.
Soraya, could you explain when the answer would be the maximum? Could you give us like a scenario?
What is the last number in the 5-number summary?
That's it?
Yeah, or like what is the corresponding number to the last number of the 5
Oh,
numbers?
okay.
Or
Okay.
you can ask, what is the longest length of time someone spent at Redbox or whatever? You know, like
Okay.
that's just what is the longest or whatever the max.
Mhm.
Whatever
Okay.
gives us the idea that it's the very last, the or the longest or something like that.
Cool.
Okay. Well, hey, an hour is a little better than 2 hours last week.
Yeah, that was long last
We
week.
spent a long time.
Oh, doing standard deviation by hand and everything, huh?
Yeah.
Yes.
And we had to use SPS. Was that yet last week?
Yes.
Yeah.
In our quiz.
Did everyone get SPSS working in here?
Yeah.
Okay.
Yep.
I just want to make sure. There's a lot of groups who are having issues with this, so I just want to make sure.
Yep.
Okay.
No problems. All right. We're
I think we're
good?
done. We good?
Yay. Okay.
All right.
Okay. Bye.
Bye,
Bye.
everybody. Bye,
Yeah,
Sarah.
thanks, Soraya.
Bye.